Hi, here's a quick tutorial on how to solve simultaneous equations, and I would like to use this time to explain what simultaneous equations are, or sometimes we do refer this to as systems of equations. So generally we have always been accustomed to solving equations with one equation and simply one variable, which could just be like x or y or any other variables that we see. So for instance, if we look at 2x plus 5 equal to 9, we know that we can easily solve this equation by subtracting 5 on both sides. Okay, and that gives me 2x equal to 4, which gives me x equal to 2. Now this is relatively straightforward, which you have done so probably in middle school. But looking at solving systems of equation by what it means by systems of equation when it comes to solving them, in this course or in this tutorial, what I would like to show you is how you could solve system of equations with two unknowns. So this probably will look something like that. So if I have an equation that looks like 2x plus y equal to 8, I could have something which looks like this, which is 2x plus 4y equal to, I'm just thinking of a nice little number here, so maybe it could be 14. Okay, now the idea of solving systems of equation, okay, having the first equation, let's call this equation 1, I'm going to call this equation 2. My objective is to find the values of x and y which will satisfy both equations at the same time. Okay, so whatever x that you found should go into equation 1, and whatever you got for x and y should also go should work for equation 2 as well. Okay, so equations 1 and 2. Now there are two algebraic methods to solve this. One is something what we call the elimination method, and the other which is called the substitution method. So I'm going to use this opportunity for me to quickly skim through these two methods, and hopefully this will be a great revision tool for you as well. Alright, so let's analyze what the elimination method works for this one, for this particular example here. Okay, so now for the elimination method, what it really does, I'm just going to write down the equation again. 2x plus y equal to 8, 2x plus 4y equal to 14. Now the idea of this method is to try to eliminate, we are aiming to eliminate one variable, because we know that if we got one variable to be eliminated, then it's probably going to end up looking something like that again. Okay, so again, if we look at these two equations, we got 2x plus y equal to 8, 2x plus 4y equal to 14. Now, what I would like to look at is that if you look at the first equation and the second equation, they have something in common, which is 2x in both of these equations. So it's probably sensible to try to eliminate this variable if both the equations have the same term. Okay, now the other term, which is y and 4y, I mean, technically speaking, we could make y to be 4y if we multiply the y by 4, but that seems to be a lot of work. So what I intend to do now is, since we have a common term in both equations, I'm going to try to eliminate these two variables here. Now, so if I have 2x, this is positive 2x for both of these equations, and the other is also positive 2x. Now, if you have a choice between addition or subtraction, what will you choose in order to eliminate 2x? Because to eliminate 2x means that ultimately what I'm looking at is for them to be 0. So we know that for 2x to eliminate 2x and wanting to get that to be 0, the obvious choice is we're going to subtract them. Okay, now does it matter if you take the first 2x, subtract this 2x, or does it really matter if you take the second 2x, subtract the first x? It doesn't really matter in this case, because both of them are just positive 2x. Okay, So just for demonstration purposes, what I will do is I'll take the second term, which is this 2x, and I'll subtract the first 2x. There is a reason why I do that, okay? Now, because the thing is, if I have decided to choose to subtract the 2x, and I'm going to take the second 2x, subtract the first one, I need to do the same thing for the rest of the terms as well. So what I'm saying is that, let me use a different color, is that since I have decided to subtract this 2x to this 2x, I'm going to do the same thing for 4y and this y as well. So I'm going to take 4y, subtract y, and that is also going to give me equal to 14 subtract 8, and that gives me 3y to be 6, and y would be just simply 6 divided by 3. Now, by doing the subtraction right from the first step here, we have eliminated the term 2x. Okay, now you might say, does it matter if I take the first one, subtract the second one? It doesn't really matter. It actually gives you the same answer as well. So if I were to take the first 2x, subtract the second 2x, then it's going to end up looking like taking y, subtract 4y, and I'll take 8, subtract 14. Now the only downside to this is that you will end up with negative terms, which may be uncomfortable for some of you. Okay, so you're going to end up getting like 3y to be 6, and you're going to get y to be 6 divided by 3, which gives me 2, which ends up to be the same answer. Okay, so having found y, we need to find x, isn't it? Because ultimately we're trying to find what is x and y. So I'm going to substitute y equal to 2 into, it could go to any of these equations here. You could choose the choice of equation 1 and 2. So I'm going to substitute that into equation 1. And it really doesn't matter if you choose 1 or 2. So you're going to have 2x plus 2 equal to 8. You're going to get 2x equal to 6. And you're going to get x to be 6 divided by 2, which is 3. Okay, so I'm going to get two answers for y and for x. Now, a good way to check if you're getting the answers right is to put these two answers into equation 1 and 2. If you could get the same, I'll just show it to you for demonstration purposes. So if x is 3, y is equal to 2. What I'll do is, if I want to check my work, I could do like 2 multiplied by 3 plus 2. That gives me 8. So this works for equation 1. I'll do that for the second equation, which is 2 times 3 plus 4 times 2. So that gives me 6 plus 8. That gives me 14. And that works for equation 2 as well. So if I know this works, I'm bound to get the answers right for x and y. Okay? So that literally is what is the elimination method would look like. Now, I just do want to touch on the different variation on how the elimination method works as well, just to give you a rough sense. So if I'll give you an example here, which is 3x plus 4y equal to 7, and I have 5x minus 2y equal to 16. Now again, the same thing works, but the only downside to this question is that isn't a common term between both equations, because this is 3x, this is 5x, this is 4y, this is 2y, and this is 7. This is this really doesn't matter, but again, we're focused on these two terms here. Okay, now they don't really look the same, but can we actually try to make them the same? I think we could do that. So what I could do is I'm going to make 4y and this 2y to look the same, and the most sensible way to do this probably is to multiply this by 2. Alright, so as we could get 2y to become 4y, but if we multiply to 2 to one of the terms in an equation, then I need to multiply this by 2 as well, and I need to multiply this by 2 so as to balance the equation. So if I rewrite the question, it's going to look something like that, which is 3x plus 4y equal to 7, and I'm going to get 10x minus 4y equal to 32. Okay, and now we have the same thing again, which is 4y, and I have negative 4y. So what I'm going to do this, I'm going to do this again. I'm going to have the first one be 4y, the other term to be negative 4y. I'm going to try to find a way to eliminate both terms. which makes it to be 0. Now, if again you have the choice between addition and subtraction, what would you have chosen for this? To eliminate 4y. In this case, I would have chosen a plus sign, because we know that a plus sign and a minus sign, this basically gives me a minus or a subtraction, so you're going to end up getting a 0. So what I'm essentially doing is, if I add 4y to negative 4y, I would have eliminated these two terms. Okay, so again, if we decide to do addition, then I will need to do so for 3x to 10x, as well as 7 to 32. So it will look something like that. 3x plus 10x equal to 7 plus 32. That gives me 39, which means that x would be 39 over 13, which gives me 3. Sounds good? Okay, so what I'll do next is as well is to find y. So sub x equal to 3 into, now you may ask which equation should I substitute, because now I actually do have like several equations in this question, and it's really your choice. You could either use this equation, you could use this equation, you could use this one, which is essentially the same one, or you could have used this one, and it doesn't really matter. But I would always suggest that maybe find the one that has the smallest numbers in the terms, which might make the calculation so much easier. So I'm probably going to substitute that into the first equation, which looks like that. Okay, so this becomes 9 plus 4y equal to 7. Then we could do the math for this one as well. So it's going to look something like 4y equal to negative 2. So you're going to get y equal to negative 2 over 4, which gives me negative half. Okay, and I will always recommend you to check your work, as always, by substituting the numbers into the equations to verify the answers. Okay, so that essentially is the elimination method for this. There are different variations, but they all generally work out to be the same thing. Okay, now what I would like to spend maybe just the next 3 minutes is to really kind of skim through what is the substitution method and why do we even do that in the first place. Okay, now so the substitution method is another technique for you to solve the system of equations for this. So if I have 5x minus 2y, for instance, equal to 34, and I have x equal to 3y minus 1. Now what I could do as well is, if I want to do the substitution method, now it's kind of obvious, is that if this is called equation 1 and this is called equation 2, now they look quite different from the elimination method, is because the x and y in the previous examples tend to be on the same side of the equation. But if you look at the substitution method, the x and y happen to be on the different sides of the equation. Now, there is nothing wrong in doing elimination method for this question as well, because you could essentially do that, and it will look something like this, which is 5x minus 2y equal to 34. You could have x minus 3y equal to negative 1. And we do the same thing again, is to try to find a common term by using the same technique that I've just taught, and do this by the elimination. But sometimes the question might indicate you to do the substitution method in particular. So if you are asked to do it by substitution, then well, we have to follow the instructions to the question, isn't it? Otherwise you might lose points in the test or in an assessment. So let me just show you how the substitution works. I think the fact that it's called substitution means that we're trying to replace one variable with another variable. Does that kind of make sense? Now the trick comes to this, which is equation 2. We know that x can be written as 3y minus 1. So what I'll do is I'm going to substitute equation 2 into equation 1. So I'm going to replace this x here with 3y minus 1. Now, does this kind of ring a bell? This looks like what we have done before with solving equations with one unknown. So it will look something like that. Okay, so we know that 15y subtract 2y, that gives me 13y. And we know that we can add 5 on both sides. So you're going to get y to be 3. Okay, and again we do the same thing by finding x, and we can put this number or substitute this number into the second equation, which is 3 multiplied by 3 subtract 1, which gives me 8. So essentially that what is substitution is all about is if you could make a variable the subject of the formula, or in terms of the other variable, it makes sometimes substitution might end up to be easier because it eliminates one of the variable just by the fact that one of the variable has been written in the form of another variable, if that kind of makes sense. Okay, so but I would like to show you a different variation, just one more variation for me, a harder one, and it will look something like that. Now, and you will have to determine which method is actually a more preferable one. Now, again, if I look at this equation, it looks complex, okay, because you have all the terms on one side of the equation. Now, ideally, we have not done something like that. Now, but we could have just try to get these numbers, and let's see if we could have these constants to be simply only on one side of the equation. Okay, so what I would do is I'm actually going to now for the first one, I'm actually going to subtract 6 on both sides, because if I subtract 6, this is going to remove the 6, and I'm going to subtract 6 as well, so I'm going to get equal to -6. And the same thing for this is going to get 3x minus 2y. If I add 23, I'm going to add 23 here as well. Okay, now this rings a bell because I could possibly use the elimination. Okay, now the question now again comes down to, what if the question says that you need to do it by the substitution method? Okay, then we need to have a change plans for this. Okay, so let me just show you how we can do it with the substitution method. Now again, you could choose either equation, which is the first one or the second equation. The objective is we could either make x or y the subject of the formula. Okay, now there is no right or wrong whether you want to make x or y to be the subject of the formula, but then again, we always try to make our life easier by choosing the one that perhaps has the smallest term. Now, we do know that we have 3x and -2y, which looks fairly decent. I'll just show you exactly how we could change the subject of the formula for this one. Okay, now again, the choice could be either using this one or perhaps this one. It doesn't really matter. Okay, I wouldn't have used this because it's still quite complicated. I would suggest using this variation so that it makes x or y the subject of the formula so much easier as well. Okay, so either equation works, but I'm just for demonstration purposes, I'm just going to show you one. Okay, now let's say we take the first one, which is 5x plus 3y equal to -6. Now the idea of this is, let's say if you want to make x the subject of the formula, which will look something like that. So we 5x equal to -6 subtract 3y, then x would become -6 minus 3y over 5. Okay, it looks a bit nasty because it has a lot of negative signs to it, but the idea is we are actually going to substitute this guy. So we're going to sub x equal to -6 minus 3y over 5 into this equation. Okay, into 3x minus 2y equal to 23. Okay, now I'm just going to show you how it looks like first, and you probably will appreciate why this has been done in the first place. Now, this looks extremely complicated. It comes with a fraction, okay, but the consolation for this is that only y appears in the equation, the x is gone. Okay, so if we could solve this equation, then maybe we should be able to find out what the value of y is. So what I'll do is I'm going to multiply this fraction to 3 first. So remember, when you multiply a fraction, we know that 3 is just simply 3 over 1. So I just need to multiply the 3 to the numerator. One misconception is that a lot of students would multiply the 3 to the 5. That's incorrect, okay? So that's going to just give me negative 18 minus 9y, because if I take 3 times negative 6, that gives me negative 18. If I take 3 multiplied by negative 3y, that gives me minus 9y. So over 5 minus 2y equal to 23. Now, if we have a fraction in the equation, it is advisable for you to try to remove the fraction or to eliminate the fraction. And there's one very nice technique we could do, is to multiply the fraction here by the denominator, which is multiplying this by 5. Okay? By doing that, the denominator will be gone. The reason for that is, if you think about this, if I take 2 over 5 and I multiply this fraction by the denominator, you realize that this is going to turn out to look like just simply 2 times 5, which is 10 over 5, which gives me 2. Alright? This kind of cancels out each other, and I'm just left with 2 here. The same fundamental applies here. If I multiply this by 5, what I'm only left is just going to be negative 18 minus 9y. But not forgetting, if we multiply 5 to this, we got to multiply by 5 and 5 to the rest of the equation. I'm going to get something like that. Okay? Then this is great, because we can just combine the like terms together, which looks something like that. I'll have the numbers on one side of the equation, which looks something like this. So negative 19y equal to 133, and to find y, I can take 133 divided by negative 19, and that will give me negative 7. Okay? And again, if I want to find x, not forgetting, we do have this right from the start. We can easily find x by taking negative 6, subtract minus 3 times negative 7, and I'll divide this by 5. So that should give me the value of 15 over 5, which gives me 3 and negative 7. And again, we'll check our work by substituting these numbers into the equations that we had here. Okay? Now, I hope this gives you a nice understanding of how both the elimination and the substitution work. It's quite obvious that the substitution may require more work when it involves like a fraction. So my takeaway from this is that whenever possible, if the question did not state which technique or method to use, I would suggest using the elimination method. But of course, if the question states otherwise, then we just simply have to follow the instructions to the question that is required of it to do the question as well. So I hope this crash course gives you a rough sense on how to solve simultaneous equations or system of equations by both the elimination and the substitution.